Alright, so today we are going to be looking at the first set of notes here in section 5.4, which is solving radical equations. Okay, so this is something that's pretty straightforward. You're just solving equations, so you're looking for your variable, typically x. There just happen to be some roots in your equations. So kind of our main idea here, before we get x by itself, we're going to try and get the radical alone. That's going to be kind of our first goal, and then from there we can get the x alone. So let's look at some examples here. So the first one, we have 2 times the square root of x plus 1 equals 4. So my initial goal here is I want to get that radical by itself. So I'm going to divide each side by 2. So I now have just the radical alone. 4 divided by 2 is 2 here. Now once that radical is by itself, I want to think about how I would undo a square root. The way to undo a square root is to square something. So if I did that, you can kind of think about them as canceling each other out, and I would just be left with x plus 1. And that's okay as long as on the right side I'm also squaring. So from there, when we subtract 1, we would just get x equals 3. Pretty straightforward. Let's look at another one then. So if we now have the cube root, 2x minus 9 minus 1 equals 2. Okay, so again, we're trying to get that root by itself, so that would be this whole piece here. So to do that, we would add 1 to each side. So we'd have the cube root of 2x minus 9 equals 3. Okay, very similar to the square root, except for since this is a third root, I have to raise that to the third power, meaning the 3 also has to be raised to the third power. So then those would cancel, and I would have 2x minus 9 equals 3 to the third is 27. And then from there, you're just solving like you normally would. So add the 9 to each side, divide by 2. Let's just try a few more here just so we can get the hang of this. This one is 2 times the cube root of x minus 3 equals 4. So to get that root by itself, I'm going to divide each side by 2. So the cube root of x minus 3 equals 2. To get rid of that radical, since it's a third root, I'm going to raise it to the third power so those undo each other. So I get x minus 3 equals 8. Add 3 to each side, so we have x equals 11. And let's try just one more basic one here, and then we'll get into a word problem. So the square root of x plus 25 equals 2. Okay, so this is just a square root, so now I need to square it for them to undo each other. So I would have x plus 25 equals 4. Subtract 25 from each side to get x is negative 21. Alright, for this next example, we're going to look at a word problem. So in your textbook, I want you to turn to page 266. We're going to be looking at number 14. So go ahead and pause so you can find that, and go ahead and read the problem so you know what we're looking at here. And then come back and let's take a look at it. Alright, so now that you've read it, what we need here pretty much is the equation that they give us to represent that maximum speed they're calling v. So they tell us v is equal to the square root of 2gh. So then we need to figure out the things that they are telling us then. So they tell us gravity g is 9.8. Okay, and since there's 3 variables here, they must give us another someone there. They say determine the height at the top of the swing for a rider whose maximum speed is 15. So that's v. They tell me v is the maximum speed. So I know G and V. So basically, I'm just substituting into this formula to find H. So I'm going to substitute in 15 for V, 2. I know G is 9.8. And then I'm trying to find H here. So, since that radical is already by itself, I'm going to square each side. So 15 squared is 225. Those then cancel, so I have 2 times 9.8 equals H. I'll go ahead and do that. 2 times 9.8, which is 19.6. Divide each side by 19.6. So I get H is equal to 11.48. I want to have some units on here since this is an application problem. So you want to look back and see, what did H represent again? It says where H is the height, and then in parentheses it says in meters. So this would be 11.48 meters. All right, so now we need to look at the situation when there is more than one x when we're solving. Okay? So the first few examples we did, there was only one x and it was under that radical. Let's look at what happens when there's more than one x, one under the radical and one not. So let's say we have x plus 1 equals the square root of 7x plus 15. Okay? So that radical is technically by itself here. It just so happens that there's an x on the other side of the equation. So we're going to approach this the same way. But now I have to think about, when I square this, I am just left with 7x plus 15. But when I square the left side, that means I would have x plus 1 times x plus 1. So I would need to do all of this multiplying in here. So that's going to give me x squared plus x plus 1. Is equal to 7x plus 15. So I'll simplify this. X plus x is 2x. So in order to solve this quadratic, I'm going to have to do something like quadratic formula, factoring, completing the square, any of those things that would apply. In order to do that, I want one of my sides to be 0. So I'm going to subtract 15 and 7x. So it'll give me x squared minus 5x minus 14 equals 0. Okay, and this one ends up factoring nicely here. So I want to think about two things that multiply to be negative 14. I know 7 and 2 multiply to be 14, and they have to add to be negative 5. So if I do x minus 7 times x plus 2, okay, because negative 7 times 2 is negative 14, negative 7 plus 2 is negative 5. So from here, I would set each factor equals 0. So I would get x equals 7 and x equals negative 2. So here's the deal, though. We're not quite done. So it is possible to have two solutions on these, but sometimes we get something called an extraneous solution, and that happens from squaring that variable that we did in the very first step when we did that x plus 1 squared. So with these problems, we have to do a little check to make sure that the answers we come up with satisfy our original equation. So when I plug 7 back into that original equation, so we had x plus 1, so that would be 7 plus 1 equals the square root of 7x, so 7 times 7 plus 15. So we're just going to verify that that is true. So the square root of 49 plus 15 would be the square root of 64, and the square root of 64 is 8. So this one does check out. So I'm going to circle x equals 7 because that one works. I'm going to try the same thing with negative 2. So I would have negative 2 plus 1 equals the square root of 7 times negative 2 plus 15. So I would have negative 2 plus 1 is negative 1 times the square root of negative 14 plus 15. So I have negative 1 equals the square root of 1, which is not true. That one did not work. So I would just cross that off and write extraneous. So extraneous has the word extra in it. It's an extra solution. Sometimes they work, sometimes they do not. So you just have to check them. All right, let's try another one like that. So we have the square root of 10x plus 9 equals x plus 3. So same idea, we have x on both sides. To get rid of that square root, I know I'm going to have to square each side. So here I'm left with 10x plus 9 because that's square root and squaring undo each other. And here, x plus 3 squared would mean I have 2x plus 3's. So when I do all that distributing, I would end up with x squared plus 3x plus another 3x plus 9. So 10x plus 9 equals x squared plus 6x plus 9. And now, since I have that x squared and that x, to solve that quadratic, I'm going to want to get everything on one side, so my equation would be equal to 0. So when I subtract the 10x, I end up with negative 4x. And when I subtract the 9, I would end up with 0. So it's just x squared minus 4x. So this one, when I factor it, is easier. Because there's no constant, I can just take an x out of both of those terms and end up with x minus 4. So my solution would be x equals 0, or x minus 4 equals 0, or x equals 4. And then the same idea, we want to check both of those then. So when I plug in 0 to my original, that would be the square root. That's my check. So the square root of 10 times 0 plus 9 equals 0 plus 3, which we know 10 times 0 is 0. It would just be 9 under the radical. The square root of 9 is 3. 0 plus 3 is 3, so that one checks out, so 0 works. Let's check 4. The square root of 10 times 4 plus 9 equals 4 plus 3. So this would be the square root of 49 equals 7, which is true. So we have two solutions here. So if you think about why that might be true, we know the graph of a square root function kind of has, so the parent function has that general shape. And we said this was equal to x plus 3, which is something linear. So it's possible that something linear could go through that graph twice. So that line wasn't a very good example, but you could hit there and then hit again. So that's really what we're looking for, is where these two intersect. So it's possible that we end up with two solutions. It's possible that we only end up with one solution. It would also be possible that we end up with no solutions if you have something that never intersects. Think about a line like that. Okay, so if we got answers and neither of them work, that is a possibility. All right, one more thing to check here. So solving with rational exponents, and we've seen this a little bit. So let's look at our first example here. So we have 2x to the power of 3/4 plus 2 equals 10. So same idea, I want to get whatever's being raised to that power by itself, so I'm going to subtract 2 from each side. Okay, now instead of just squaring or cubing something, here since the root is 4, I'd be raising it to the 4th power. That's not going to get rid of that 3 for me. So what you want to do is you want to raise it to the reciprocal power. So for here, if this is to the power of 3/4, I want to raise it to the 4/3 power. Because when I have a power to a power like that, I would be multiplying. And 3/4 times 4/3 is just going to be 1. That's going to cancel everything out. So I would just have 2x equals, and now let's break this down, the 3rd root of 8 to the 4th power. So 2x equals, the 3rd root of 8 is 2 to the 4th. 2 to the 4th is 16. So x is just 8. Alright, let's try another one here then. So we have x plus 30 to the 1/2 equals x. So this is kind of a combination of the last two things we've done here. So I have a rational exponent, but I also have x in two different places. So we're going to start by raising it to the reciprocal power. The The reciprocal of 1/2 is just 2 over 1, or 2.